day 40. I'll find out and post it. So today we're going to be solving subsets, and it says, given an integer nums of unique elements, return all possible subsets to power sets. So the solution set must not contain duplicate subsets. Return the solution in any order. So let's get into it. This type of problem, I'm going to solve it using backtracking. So backtracking is basically creating different processes. Let's look at it together because I was studying it a while back. So there are problem solving strategies. This is distracting. There are problem solving strategies that explore different options to find the best solution to something. So for example, I have a way I'm doing something, then if it changes, I find a solution to something, it works. For the other solutions, I probably have to change my approach to it. So this involves doing different options and undoing them if they lead to a dead end. Okay, and so this is how it works. So you choose an initial solution, you explore all possible extensions of that current solution, and if an extension leads to a solution, return it. If it doesn't lead to a solution, if that extension doesn't lead to the solution, you backtrack to the previous solution and try a different extension, and you keep on repeating this until all the solutions are explored. And so that's what we're going to do today. So over here we see that when one is we start with an empty array, then we add the first element 1, second element 2, third element 3, then we start adding it in sets, but the sets are not duplicates, right? We want to make sure that there are no duplicates at all. So the first thing I'm going to do is I'm going to have an array that where I store my results, because the output is going to be an array. Then I'm going to have a subset, so I'm going to actually be returning the value of subsets, right? Different subsets inside my results array. So I'm going to create function def dfs, and I'm going to put I in here. And so what I'm going to say is, I'm going to say if I is greater than the length of my nums array, I am going to append a copy of that subset. So for example, res dot append subsets dot copy, and I'm just going to return that. Then if so, what's going to happen is I'm then going to include nums I. So I'm going to include nums I. So I'm going to say subsets. So now I have different decisions I'm making right now. For some decisions I am adding nums I. For some decisions I am removing values from it. So I'm going to add, and then I'm going to call this function again, but for I plus 1, and then I also have the decision not to include nums I. I also have the decision not to include nums I in this. So I'm just going to say subsets dot pop, and then dfs I plus 1, because I want to keep going. Then what's going to happen is I'm going to call this out, but I'm going to call it out on 0, 0, and then we're going to return res. Let's see. So if I is less than or equal to this, and it worked, right? So you see I'm trying different approaches here. So I'm appending things and popping things out. It's basically testing different approaches until I get the finalized one. So thank you for watching. I'll explain it more in the chat, like the detailed steps on what I took to solve it.